Hi everyone, this is Ezekiel O'Callahan with Raptor Chatter, and we're going to be looking at what happened in June 2021 in paleontology. And so without any further ado, let's get started. Pelecaniformes is a group that includes a lot of different birds, and it actually started just after the KPG extinction. And so some of the first emerging members were things like the herons and the ibises, but then later other animals, such as the hammerkop, which is functionally very similar to herons, and then also the shoebill stork, which is also functionally very similar to herons. And then finally you get to pelecanidae, or the pelicans. So it's a whole bunch of waders, and then very suddenly towards the end of this group, pelicans. A new species of fossil pelican named Eopelecanus aegyptiacus is the oldest known member of Pelecanidae, and you might have gotten this from the name, but it comes from Egypt, and specifically from the same group of information that we actually find a lot of Basilosaurus fossils, and Basilosaurus was an early whale, so we actually can understand that these animals were evolving at right around the same time. This time period correlates to the late Eocene, so you know by at least that point, the modern diversity that we do see in Pelecaniformes had already evolved, and so it's very probable at least that the other groups already did exist in the fossil record too, although we may not have all of those fossils just yet. And as for fossils in other groups that help us to understand the broader diversity of a group, we have a new fossil crocodilian coming from Australia. And this might seem not that exciting because crocodilians are actually one of the groups people most think of when associating an animal with Australia. But so far it's only been understood that two groups actually made it to Australia. And those would be the ancestors to the freshwater and saltwater crocodiles, and then another group that's now extinct, the Mecosukines. The Mecosukines were land-based, and they actually lived up until just a few thousand years ago, meaning they would have interacted with some of the first people to actually make it to Australia. But beyond that, this new fossil isn't either of those groups. It's a tomistomine, which means it's very closely related to the falsarial, or at least closer related to the falsarial than any other modern crocodilians are today. The new species was named Gunganmarandu monala, and comes from only 2 million years ago, so not that long in geologic time, although it did go extinct before humans showed up on the continent, at least probably. But while I said this animal was very closely related to the falsarial, or closer than other crocodilians were, it's still separated by a lot of time, almost 50 million years to its closest relative in the group Tomistomine. So while this animal was a tomistomine, and its closest modern relative would be the falsarial, it still wasn't that closely related, because the tomistomines actually had a lot of diversity, including its closest relative to Gunganmaru, which came from Europe over 50 million years ago. That animal was Dolosuchoides, and coming from Europe, that means there's a massive gap in the geologic record for how these animals migrated from Europe into Australia, and that means there may be dozens of more fossils that we could try and find from this specific lineage to try and understand how they got from point A to point B. There were also a number of papers this month looking at trackways and trace fossils in the geologic record, and one of these actually looked at dinosaurs that were walking through large sand dunes. This paper talks about South American trace fossils, and the most interesting thing about it isn't necessarily the track makers themselves, but rather how they were identified. And that's because most of the time when you see trace fossils laid out, they're on a flat slab where you can see the indentation into the sediments. This isn't the case for this particular formation though, because most of the outcrops for this formation are essentially cut in half. And that means you're, instead of getting the top view of a footprint, you're getting the side view. And so you have to try and understand how different things like underprints are formed in order to identify these kinds of trackways. An underprint is essentially the soft sediment deformation that happens when an animal walks across multiple layers of sediment and doesn't necessarily punch through all of them. So what we can imagine is essentially if there's 3 layers of sediment and the animal punches through 3 layers, the weight of that animal is still going to shift the lower layers, even if it didn't necessarily touch those layers. And that kind of deformation of those lower layers are the underprints that these authors are specifically talking about. Now, the reason they're able to say that these are dinosaur footprints is because it's from the right time during the Cretaceous, and also there's not really a whole lot of other animals that were that large that it could be from. So it's very likely that these were dinosaur-made footprints, although we'll never technically know for sure unless we're able to do some incredible 3D imaging or something of these trackways. Another paper looked at mammal trackways in tuff, and that's Tuff, tuff. And tuff is a very strange rock to get fossils in because it's generally very soft and also it's volcanic, so most animals don't necessarily want to hang around when tuff is being formed. And tuff can be formed in 2 ways essentially. The first is pyroclastic flow. So if you think of the Mount St. Helens eruption, that's a very large pyroclastic flow. The other is ashfall. And so if you think of some of the volcanoes that have erupted in Iceland where they shoot up giant ash plumes, where those deposits are the thickest, that will also form a tuff layer. But again, these are soft and not necessarily that likely to preserve fossils, but sometimes they do, or at least they preserve trace fossils, and what animals were walking across the tuff as it was being deposited. These fossils come from Olduvai Gorge, very close to where the first hominins are found, and only 1.8 million years ago, so also at the same time that those first hominins were actually around. These prints aren't hominin though. Instead, they're actually from artiodactyls, so animals with an even number of toes on their hooves, so things like camels or buffalo. This is actually really unique because it helps us understand what the other animals that were living alongside the earliest hominins would have actually been, and hopefully can help us to understand what the greater environment that humans eventually evolved in was actually like. And again, this is largely due to the very unique preservation occurrences that are happening here, because again, tuff isn't very likely to preserve fossils, although there is at least one other older tuff formation that does preserve some fossils, and you may hear a little bit about that in the future. Another trackway actually has something to do with one of the things I did an entire separate video on, and that's the Winton Formation. And the Winton Formation is in Australia, and there's a large number of dinosaurs that are actually found in this formation. But most of the trackways have basically been theropod and ornithopod dinosaurs. Now though, there's at least some more diversity to this. And in fact, it's a lot more diversity, including things that aren't even dinosaurs. The new site also does include those theropod and ornithopods, but it also includes things like sauropods, crocodilians, accineropterygians or ray-finned fish, and some lungfish feeding traces. So it helps to show that there's a very diverse fauna present in the Winton Formation, and that we shouldn't be limited to just what we find in the fossil record, or as far as body fossils are concerned. There's more diversity than just body fossils. Additionally, the sauropod prints may be totally unique, at least unique enough to give them their own scientific name, although it's really hard to tell because they are somewhat poorly preserved. A lot of this is based on the fact that some of them do appear to still have the thumbprint. Some sauropods had a large thumb claw, and it seems like that mostly evolved out of the Australian sauropods, although it has been suggested in one, Diamantinosaurus. So these prints may actually correspond to that specific animal, although it's really hard to tell because they are poorly preserved. Hopefully there will be more fossils coming out of this site though, so we can try and get a better understanding of what was happening with the sauropods. Regardless of this though, it does help us to understand the broader diversity and very complex ecosystems that were present in the river plains of Central Australia during the Cretaceous. There were also a number of trackways coming from China, the first two in the Sichuan province and specifically in the Jiaguan Formation. Now this formation is known for having a lot of theropod tracks, but not really any bodies, and this still holds even with these new fossils. These are theropod tracks, and they're really poorly preserved, so it's hard to say exactly what was happening, and part of that might also just be because they were found in very unique locations. One was essentially on a cliffside, and the other was in a cave. But it has helped to show that there are fossils that can be found in many different places, and it's important for us geologically to go and explore as many of these places as we can, so we can try and find more unique fossils in the future. The other set of tracks also comes from the Jiaguan Formation, but this comes from just across the border from the Sichuan province in Guizhou. These are also theropod tracks, but these ones we can actually say at least what they probably belong to, and that's the raptor dinosaurs, and that's because they only have 2 toes. In general, theropod tracks are really hard to try and tell apart because it's essentially a 3-toed foot with claws at the end. But because the raptors very distinctly held up their sickle toe claw, it makes it very easy to identify their footprints in the fossil record. So we can say with some confidence there was some type of raptor dinosaur in the Cretaceous in central China. And that's even despite not having any real body fossils from this part of China for that time period. And now on the subject of raptor dinosaurs or dromaeosaurs, there was a new one described named Kansaignathus sogdianus, coming from a Soviet expedition to Tajikistan in the 60s. Now, this paper is still in Russian, so I can't quite look at all of it. However, from what I was able to translate, it does seem like it is its very legitimate own genus, and that's because it had 12 alveoli in the jaw, and that's different than the numbers we see in other dromaeosaurs. Now, alveoli are essentially just where the tooth would have fit its tooth sockets. So it's not anything that's wildly complex, but the number of them is very diagnostic, at least within some dromaeosaurs. It was also closely related to Velociraptor, as in it was a velociraptorine dromaeosaur, although it lived about 10 to 15 million years before Velociraptor, although still in large parts of Central Asia, meaning that there may be a consistent pattern of these very small or relatively small turkey-sized dromaeosaurs showing up in this part of Central Asia during the Cretaceous. So earlier this month, I also had a video on Burmese amber and the ethics surrounding it. And this was under the lens of 2 papers. And so now I'm actually going to talk about the science in those papers as opposed to just the ethics of those papers, which you should absolutely check out. I really like that video, and I think it's a very important subject. As for the papers, the first one didn't have any ethics statement, and so I'm not going to go as far into it. This paper described a new species of fossil bird. It was named Fortipesavis prehendens, and beyond that I'm not really going to discuss too much about it because of the ethics issues surrounding this paper. The other paper, though, did have an ethics statement, and what it found was actually pretty interesting because it has to do with a fossil found last year, Oculudentavis. Oculudentavis was originally described as the smallest bird in the fossil record, and immediately a lot of people pointed out that that's probably not a bird. And this new paper actually describes a new species of the genus Oculudentavis, this one being Oculudentavis naga. The new species of Oculudentavis naga, has a much different skull shape than the older species, Oculudentavis congrae. And it does help to show that the genus did also have more lizard-shaped skulls as opposed to the more bird-like skull of congrae. However, there's also 7 other features that were found in naga that help to suggest it was actually a lizard. And a lot of these have to do with cranial kinesis. Cranial kinesis is something that's very common in the lizards, but less common in the early birds. What happens is essentially many different parts of the skull and the different skull bones can move relative to one another. The snakes, which are technically lizards, actually take this to the largest extreme, with their skulls being able to very far deform themselves in order to swallow very large items of prey. This still happens to some degree in lizards, although just a smaller degree. The early birds, though, didn't have this, instead having a more solid and rigid skull, much like the dinosaurs had. And so this is a really good indication that Oculudentavis wasn't actually a bird, but instead is actually a lizard. And now looking at the extinction that killed the non-avian dinosaurs, there's been a lot of evidence that has suggested that most environments were pretty stable during the late Cretaceous, and then suddenly they got hit by a giant rock from space. But overall, without that rock, they probably would have sailed on just fine. A new paper, though, looked at this through the lens of biodiversity, so essentially how diverse and how speciose are the dinosaurs during this time period. And they found that about 10 million years before the impact, there's actually a pretty significant drop in diversity. They essentially ran the data through modeling software that was used to estimate how speciose and how much speciation should have been occurring during this last 10 million years, and found that it was essentially much lower than what they had found via this model. And no model is perfect, but it's at least a starting baseline to try and work with. I do think, though, some of their data might have been off based on the 6 families they actually used, and that's because there were a lot more families still around, such as the alvarezsaurs and some titanosaurs like Alamosaurus, which were still around on North America at this time. But then in addition to that, you have some animals like the abelisaurs, which were very successful and common in South America and parts of Africa.